Okay, so here in this video we'll be talking about logarithms, since in the previous video we talked about how to solve exponential equations with logarithms. So as you recall, previous video, log is always going to be in the standard form of log A of B is equal to C, where B is equal to A to the power of C. So here we can go ahead and just use this whenever we want to find what b is, in case we have any log of expression that shows like x as b. So we have 6 of x minus or equals 4. We can just take 6 to the power of 4, which is about, let's see, x 6 cubed is 216, so 6 times 216 is about 1296. Since that is what 6 times 216 is, where we can just plug in whichever we want, 6 to the power of 4 or 1296, and still get 4 as an outcome. And there are some logarithms where they aren't going to always be like this. So here we're going to look at a example where we have a difficult one. So here we have a quadratic inside plus 2x plus 1 is equal to 2. Or actually, yeah, we're going to have 2. So here, we're going to have to basically solve for x to see which of these equations or which of the solutions in the equation make the equation true and make it equal to 2. So here we're going to go ahead and solve this example. So we have log 2 of, let's go ahead and factor this out, but here we basically can just go ahead and complete the square or use the quadratic formula. But I'll tell you how to solve this quicker after, since it involves a little bit of memory. So we have x squared plus 2x plus 1 is equal to 0. And basically we want to go ahead and see whether we can factor this or not. But before we even solve a quadratic like this, since we have it inside the log, we always want to take the exponent, or basically multiply the equation by, or well, exponentiate it by 2, where we will be left with 2 to the power of log of 2 of x squared plus 2x plus 1 is equal to 2 to the power of 2, which just gives us x squared plus 2x plus 1 is equal to 4. Here we can go ahead and solve with the quadratic formula by moving negative or subtracting 4 to the left-hand side of the equation. But this method here is just going to tell us what solutions are true for our quadratic. So we're going to go ahead and solve using quadratic formula. So x squared plus 2x minus 3 is equal to 0. So we're going to have x is equal to negative 2 plus or minus the square root of 4 plus 12, which is 16, which is going to give us 4 over 2, which is going to give us negative 3 comma 1. Those are our three solutions. And with that, we can basically plug in which one makes the equation true, and we will see which one is false. So as we see, most of the time, like, logarithms can't have negative solutions, but that is only if it is a regular logarithm like this one as shown above. And we can go ahead and verify our solutions, since that is how we can tell which is extraneous and which isn't. And to do so, we're going to go ahead and plug in -3 and 1 into our equation. So we have, let's go ahead and do that. Let's just clear up some space and keep this. And we already know the solution, so we don't need to do most of that. So we have x is equal to -3 comma 1. So here we can go ahead and see which one is going to be true. So we have log of 2. So we're going to just look at the quadratic separately. So we could just plug in the number inside of the log. So we're going to look at -3 first. So we have -3 squared is just +9 plus 2 times -3 is going to give us -6. And we're just going to add 1. And we have this is going to equal 4. So we just put 4, which is the same thing as 2 log 2 of 2. We're just going to cancel out the 2, leaving us with 2, which is indeed our solution. So we can go ahead and just write our equation in blue to say which one is correct and which one isn't. So we have that -3 does satisfy our logarithmic equation. So now we have 1 to test out. So we're just going to have log 2 of 1 plus 2, which is 3, plus 1, which is 4, which is the same thing as 2. So we see that both of our equations, or both of our solutions, verify both of our equations that we had earlier. So we're just going to write that again in blue and just say that these are our solutions and just check mark that. So that's why it's good to first learn how to solve polynomials in general, because sometimes logarithms are going to have cubics, quadratics, but you'll never really see any higher degree polynomials other than a cubic unless you're doing a test where you might get a high degree polynomial like at least 4 or 5, but they should look something like this where we have log of 4 and x to the power of 4 plus x squared minus 1, which isn't really that difficult to solve since we're just doing a substitution, since x to the power of 4 and x squared are basically divisible by x squared. So we could basically say that a or u, we're just going to use u squared is equal to x to the power of 4, and u is equal to x squared, since basically we could rewrite the equation as u squared plus u minus 1, or we can go ahead and just solve and just plug it into our original equation from what's inside the log. But we're not going to solve that one yet. So we're just going to look at a few more examples and solve logarithms like those. But first, we will go ahead and look at some of the important properties we need to look over. And we will basically be looking at how to condense any type of logarithm and how to expand logarithms. But first, we'll be mainly talking about how to condense them and make it into one whole equation or just one whole logarithm. So we're going to start off with the logarithm of a, or log base a of b. Or actually, I'll just use u plus log a of v is going to be the same thing as log a of u times v. And for subtracting, the opposite of adding is subtracting. So we see that if we multiply when we have a positive sign, we're going to do the opposite if we have a negative sign, which is dividing. So we will get log a of u divided by v. And we're also going to look at the base of change formula, which is log a of b is equal to log c of b over log c of a, where c could be any number. So let's just write that down. C is equal to all real numbers. So C is going to be all real numbers. And we want to go ahead and just remember these properties. So let's go ahead and put them at the top right corner around here. So let's go ahead and do that. So now with that, we will go ahead and look at a few examples on how to condense and how to expand. So we're going to start off with log of x plus 1 times x minus 1. And we are asked to expand this. And all we're going to do is just look at the property we have, which is basically multiplication, meaning that x plus 1 is u and x minus 1 is v. So we can make a substitution, or we could just do it directly, but we're just going to do it directly since we know what u and v are. So we have log of x plus 1 plus log of x minus 1, and that is our expanded form. And we're going to go ahead and condense it as well. So let's just write it down. And we're going to condense it. So we're going to have log. And what we see here is a difference of squares, meaning we're going to get x squared minus 1. And that is all we're doing is we're just going to multiply x and x with negative 1 and 1 with x and 1 with negative x, since that's what we're doing for the distributive property. And that is all we have to do just to condense the logarithm to make it more simpler and easier to solve. So that is one example. And now we're going to go ahead and look at the change of base. So if I were to tell you to go ahead and change the base of this, how would you rewrite this? Well, we can go ahead and look at E and 15. Since we already have it here, A and B, we're going to rewrite it as log of 2 of 15 divided by the log of 2 of E. So that is how we could rewrite our logarithm. Since there's nothing more we can do here, since we can't basically cancel out any factors, since we can see that 15 and E don't basically go into each other. And if we were to go ahead and do E is equal to 2.71 and it continues, we will basically see that it is never going to be 15 exactly, since if we multiply it by 6 or 7, we're just going to basically end up with something that is greater than 15, which is around 19. And if we do E times 6, we're just going to get 16. And E times 5, we're just going to get 13. So we're never going to get 15 exactly. But we can, but it's going to be a different process rather than going ahead to get a numerical solution for this. So we can't really express it as anything else. So that's all we have to do just to change the base. And you could use a change of base formula to make the logarithm much more helpful and much more easier to solve. And we're going to go ahead and do a few more examples before we wrap up with this video. So we're going to go and look at log of of what number? 7 of x cubed plus 1 is equal to 3. Here, what we want to do is go ahead and take the power, or just basically do what we did in the previous video, which is 7 to the power of 3 is equal to x cubed plus 1, since 7 to the power of 3 is equal what's inside here. Let's just go ahead and erase that line. So we have 7 cubed is equal to x cubed plus 1, where we get 343 is equal to x cubed plus 1. And now we have x cubed is equal to 342. And taking the cube root of both sides, we get x is equal to the cube root of 342, which is going to be our only solution, which is real for this equation. So we just have to plug in cube root of 342 into there, and then basically we have 342 plus 1 is equal to 343, and we just take the log of that. 7 of 343 is equal to 3, since that is 343 is 7 cubed, and that is one quick and simple example. But we're going to look at the same example but without a solution this time. We're not looking for x. If we were to go ahead and expand this, so we're just going to write expand, how would you do it? Well, we could basically go ahead and use the sum of cubes and the difference of cubes, where we have x cubed plus y cubed is equal to x plus y times x squared minus xy minus y, actually plus y. And here, that is what it is going to be. If we go ahead and factor x cubed plus y cubed, and that is going to tell us that once we have an equation like this, it is going to be, let's just go ahead and rewrite that, plus 1 cubed, since anything to the power of 3 is 1, we are going to get x plus y, which is 1, so we just have x plus 1 times x squared minus 1 times x, which is x, and y, which is positive 1. And with that, we're basically going to go ahead and get our solution. And since we can't factor this anymore, we're basically going to have the expanded logarithm be log of x plus 1 times x squared minus x plus 1. And we could go ahead and expand this one more step, which is going to be log of x plus 1 plus log of x squared minus x plus 1. So that is how to basically expand that logarithm. And it is relatively easy since we were able to see that we could use the sum of cubes formula and how it could basically be factored out into a linear factor and a quadratic. So with that, we can go ahead and look at one more example. And by doing so, we will go ahead and see how our expanding and condensing could work out. So we will get log of x plus 2 minus log of, well, we're going to do a different base this time. Log of x minus 2. Since we don't really have the same base, we're going to change the base since they are different. But it depends on whether we want to change the logarithm of x plus 2 or the log of x minus 2 since they both have different bases. But it is up to us to see whether we want to go ahead and change the base for. So in this example, we're going to change the base for 7, where we will get log of x plus 2 minus log, we're going to change the base to be 10, so we'll just leave it empty. So x minus 2 and log of 7. And our final step is just to go ahead and multiply by log of 7 in order to have the same denominator. So we will get log of x plus 2 times the log of 7 minus log x minus 2 divided by log of 7 is going to be our solution. Since if we go ahead and separate this and look at just this part of the fraction, is going to just cancel out log 7 of 7. But for now, we're going to leave it like this since it is our answer, since we went ahead and expanded it. And we were supposed to go ahead and condense this, but we ended up getting a log where we had to condense, or not condense it, but go ahead and expand the whole equation since they had different bases. And what we could go ahead and do now is just basically say that this is our solution that we received from just this log right here. So with that in mind, we were able to understand the main properties of logs, which is just first condensing and also expanding since this is being condensed and this is being expanded. And we also learned the base of change formula. And we were able to solve a few logarithms, but also see how we were supposed to expand and condense them. So with that, thank you for watching this video and I hope you have a good day.